told that the equation x squared plus 2x plus 5 equals 0 has roots alpha and beta, and then essentially we're asked to find a quadratic that has roots alpha squared and beta squared. There's two approaches for doing this. You can use the sum of roots formula, or you can use the substitution. I'm actually going to use the substitution. I think it's a little bit quicker, but we'll see. So what I want I've got x has got roots alpha and beta. So for me to get roots alpha squared and beta squared, I need to introduce w, which is then x squared, because if x has roots alpha and beta, then w will have roots alpha squared and beta squared by definition. And that means that x is going to be root w, and I can sub that in. So I'll get root w squared, which is just w, plus 2 root w plus 5 equals 0. And let me just say, w will have roots alpha squared and beta squared. Okay, now I just need to turn this into a quadratic. It's kind of a hidden quadratic at the moment. And the process is to get the square root on one side by itself. Because I can't square it at the moment. If I do, I'll get some cross terms and end up with another square root. I need to get, if I have the square root and anything else on one side and square it, I'll still end up with a square root. But if I do it like this, then when I square both sides, on the left, I'll get 4w. And on the right, well, actually, you can just ignore the negative, to be honest, and change it to a plus. Because when you square a negative, it becomes positive. So 4w will equal w squared plus 10w plus 25. Suddenly we've got our quadratic, just need to rearrange it. W squared plus 6w plus 25 is going to equal 0. I guess they have asked it at the end of the day in terms of x. So this will have roots alpha squared and beta squared. So p is going to equal 6 and q is going to equal 25. Okay, let's look for the roots formulas that exist, because we've got instead, if we have a quadratic a x squared plus bx plus c equals 0, then it can, with roots alpha and beta, then it can be shown that alpha plus beta is equal to minus b over a, and alpha beta is c over a. I'm not going to prove them here. There's some different time for that. But what I'd say is just memorize the formula that the sum of the roots is always minus b over a, and then the sum of the multiplication. Okay, this is short for like all of them. So even when you have a cubic, when you sum all the roots, you get minus b over a. And then the sum of when you multiply two of them together, even for a cubic or a quartic or whatever, is going to be c over a. Then just alternate the signs. Sum of alpha, beta, gamma equals minus d over a, and so on. So that's the one to remember, and then you can apply it to quadratics, cubics, quartics, which are the three covered on this AS Further Maths. Okay, so in our case, we've got a equal to 1, b equal to 2, c equal to 5. That means alpha plus beta is going to equal minus 2, and alpha beta is going to equal 5, just 5 actually. Then what I want is alpha squared plus beta squared, because then I can get my new values of b and a. Okay, well this is going to be alpha plus beta squared, but then I'll have to minus 2 alpha beta. Okay, you might even just start by squaring it and see what you get, and then realize that you need to minus it. But yeah, you can see I'm going to get alpha squared plus beta squared, but an extra 2 alpha beta, so I need to subtract it. And then I'm going to square that minus 2, so it'll be 4 minus 2 times alpha beta, so 4 minus 10, which gives me minus 6. And that is going to equal minus, sometimes I call it b dash, but actually I quite like just using a capital letter. So minus b over a, my new values for my quadratic. And then I can let a equal 1. that will ensure that I get an x squared here, but you typically do that anyway. Although no, to be fair, sometimes if you get an awkward fraction, then you wouldn't, but here it's -6, so we're okay. And then that means that b is going to equal 6, because then I'll get minus b over a is equal to -6 as required. So I found out two of them, and now it's just the other one. So I've got the alpha squared beta squared. That's what I'm going to need for my c over a. Well, that's just going to equal alpha beta all squared, which is equal to, I've got it here, 5, so 25. And that, like I said, is capital C over A. So because A is 1, then C is going to be 25. And I can write down my final quadratic. It's going to be 1x squared plus bx, which is my 6x, plus c, which is my 25. And we get exactly the same answer. And from there, we can say the same conclusion that p is 6 and q is equal to 25. So what I'd say is, like, become familiar with both of these methods. They have, it's probably similar amount of effort for both. There'll be times when one is definitely better than the other. Well done.